Dynamic programming language, in computer science, is a class of high-level programming languages which, at runtime, execute many common programming behaviors that static programming languages perform during compilation. These behaviors could include extension of the program by adding new code, by extending objects and definitions, or by modifying the type system. Although similar behaviors can be emulated in nearly any language, with varying degrees of difficulty, complexity and performance costs, dynamic languages provide direct tools to make use of them. Many of these features were first implemented as native features in the Lisp programming language. Most dynamic languages are also dynamically typed, but not all are. Dynamic languages are frequently, but not always, referred to as scripting languages. Although the term scripting language, in its narrowest sense, refers to languages specific to a given runtime environment. Implementation. Eval. Some dynamic languages offer an eval function. This function takes a string parameter containing code in the language and executes it. If this code stands for an expression, the resulting value is returned. However, Eric Meyer and Peter Drayton suggest that programmers use eval as a poor man's substitute for higher-order functions. Quote, object runtime alteration. A type or object system can typically be modified during runtime in a dynamic language. This can mean generating new objects from a runtime definition based on mixins of existing types or objects. This can also refer to changing the inheritance type tree, and thus altering the way that existing types behave, especially with respect to the invocation of methods. Functional programming. Functional programming concepts are a feature of many dynamic languages, and also derive from Lisp. Clojures. One of the most widely used aspects of functional programming in dynamic languages is the closure, which allows creating a new instance of a function which retains access to the context in which it was created. A simple example of this is generating a function for scanning text for a word. Function new_scanner, word, temp_function equals function, input, scan_for_text, input, word, end function, return temp_function, end function. Note that the inner function has no name, and is instead stored in a variable temp_function. Each time new_scanner is executed, it will return a new function which remembers the value of the word parameter that was passed in when it was defined. Closures are one of the core tools of functional programming, and many languages support at least this degree of functional programming. Continuations. Another feature of some dynamic languages is the continuation. Continuations represent execution states that can be re-invoked. For example, a parser might return an intermediate result in a continuation that, when invoked, will continue to pass the input. Continuations interact in very complex ways with scoping, especially with respect to closures. For this reason, many dynamic languages do not provide continuations. Reflection. Reflection is common in many dynamic languages, and typically involves analysis of the types and metadata of generic polymorphic data. It can, however, also include full evaluation and modification of a program's code as data, such as the features that Lisp provides in analyzing S expressions. Macros. A limited number of dynamic programming languages provide features which combine code introspection, the ability to examine classes, functions and keywords to know what they are, what they do and what they know, and eval in a feature called macros. Most programmers today who are aware of the term macro have encountered them in C or C++, where they are a static feature, which are built in a small subset of the language. and are capable only of string substitutions on the text of the program. In dynamic languages, however, they provide access to the inner workings of the compiler, and full access to the interpreter, virtual machine, or runtime, allowing the definition of language-like constructs which can optimize code or modify the syntax or grammar of the language. Assembly. C, C++, early Java, and Fortran do not generally fit into this category. Example code. The following examples show dynamic features using the language Common Lisp and its Common Lisp object system. Computation of code at runtime and late binding. The example shows how a function can be modified at runtime from computed source code. Object runtime alteration. This example shows how an existing instance can be changed to include a new slot when its class changes, and that an existing method can be replaced with a new version. Assembling of code at runtime based on the class of instances. In the next example, the class person gets a new superclass. The print method gets redefined such that it assembles several methods into the effective method. The effective method gets assembled based on the class of the argument and the at runtime available and applicable methods. Examples. Popular dynamic programming languages include JavaScript, Python, Ruby, PHP, Lua and Perl. The following are generally considered dynamic languages: ActionScript, BeatShell, C#, Using Reflection, CobolScript, Clojure, Cold Fusion Markup Language, Common Lisp and most other Lisps. Dylan, E. Gambas, Groovy, Java, Using Reflection, JavaScript, Julia, Lua, MATLAB, Octave, Objective-C, Perl, PHP, PowerShell, Prolog, Python, R, Ruby, Scala, Smalltalk, SuperCollider, TCL, VBScript, Wolfram Language, GDScript. See also. Comparison of programming languages. Name binding. Further reading. Lawrence Tratt. Dynamically typed languages. Advances in computers. Volume 77. Pages 149 to 184. July 2009. Many use the term scripting languages. Are scripting languages any good? A validation of Perl, Python, RexX, and TCL against C, C++, and Java. PDF. 2003 study. A slightly skeptical view on scripting languages by Dr. Nikolai Bezrokov. Programming is Hard, Let's Go Scripting, by Larry Wall. Perl.com transcript of his State of the Onion speech. Scripting on the Java platform. Java World.